Hello there, students. How you guys doing today? Thank you for joining me. It looks like today's presentation will be basic biopharmaceuticals. So it looks like this will be a three-parter for us. So this is part one of three. So hopefully you'll tune in for the other segments coming up short. So for a lot of you guys, the biochemistry of medications probably new. So I'll try to explain these things in detail. If you have any questions, just let me know. We'll go through a lot of different items, just the effects of drugs on the body or the body's effects on the drug. So we'll explain disposition, ADME, which is absorption, distribution, metabolism, and excretion. Talk a little bit about equivalent drugs, brand, generic, etc., and then a little bit on the half-life, how long it takes for drugs to get out of the body. How drugs work? Well, we can control the drug that we administer, the strength of it, where or how it enters the body, and when we deliver the medication or administer the medication to control the desired effects. So, for example, a tablet versus a suspension, if you take them both by mouth, then of course a suspension should work a lot quicker. Same with the route, PO versus IV. Definitely something administered IV would be a lot quicker. Site of action. Well, the site of action is where the drug will interact with the body. So this interaction will be at the molecular level. So not at the cellular level, that's too big, and not at the atomic level, that would just be way too small. So the drug and the receptor will need to recognize each other at the molecular level. So you can think of the drug as a key and the receptor as the lock. So some keys only open certain locks, whereas some locks can open multiple keys. Well, I mean, some keys can open multiple locks, sorry. The receptors are very selective, just like a lock and key would be. And there's going to be two main types of drugs, hence two main types of receptors as well. So if you take a look at the cell membrane, it's mostly made out of lipids. And we have water inside the cell, and we have water outside. And of course, oil and water doesn't mix. So if water from the outside tried to pass through, it'd be repelled by the lipid membrane. And if the contents inside, which is mostly water, try to sneak out, well, they'd be repelled by that fat layer as well. So the cell membrane creates that border. So if you are water soluble or protein based, most of the time you can't get through, so your receptors will need to be on the outside of the cell. Whereas if you are fat soluble, and for example, the cholesterol based drugs like estrogen, it's fat based, cholesterol based. It can wiggle its way through the cell membrane, and there's another membrane in the cell, the nuclear membrane, and fat-based drugs can directly affect DNA synthesis and expression. So these receptors would be on the inside of the cell. Drug actions. Drugs have many actions, but in order to be a drug, you have to either treat, diagnose, or prevent an illness. Whereas with supplements, they're just food supplements. So you can make general health claims, but you can't treat, diagnose, or prevent any disease with supplements. Physical action. Protective ointments. So mineral oil for diaper rash. They have something called butt paste. So it's like a petroleum gel. Creates a barrier between the moisture from the urine and the skin. Chemically react, so antacids. So if you have too much acid in your stomach, We will give you a base. So we might give you aluminum hydroxide or magnesium hydroxide. And when these two things combine, they just neutralize each other. And you get water. Interact with pathogens. So we have antibiotics. We got a lot of different types of antibiotics. But they work mainly in 5 ways. So they either will disrupt cell wall, cell membrane, protein, DNA, or folic acid synthesis to weaken or destroy bacteria. Osmolarity. So in another class, I mentioned that blood has stuff in it. Well, how much stuff is in blood? Well, that number is 300 milliosmoles. So that's a measurement of movement through a membrane, and that's called dialysis. So dia means to go through. Incorporate in cells. So anti-neoplastic. Anti is against, neo is new, plastic is formation. So cancer cells, they divide rapidly. So to suppress their replication, you'll give them chemomeds, and chemomeds prevent that cell division. Complexiation for excretion. So if you take your key and to form a complex, well, let's just say we wrap tape around it, would it still fit inside the keyhole? So if something complexes with your drug, most likely it's going to be inactivated. Modify biochemical and metabolic processes. Yeah, some things will slow you down, speed you up. Other things will affect the microbes in your gut. That'll affect a little bit of your metabolism. Receptors. So drugs can act as either an agonist or an antagonist. So my analogy for agonists and antagonists would be the gas and brake pedal. So if I activate the brake pedal, I activate it, I press it down, I slow down. So the normal processes of activation of the brake is to slow down. But if I step on the accelerator or the gas pedal, it speeds me up. But I did activate the gas pedal. Activate the brake, you slow down. Activate the gas, you speed up. But I still activated something. So let's say you're driving along on a long road trip and you're going to get a drink of water from a water bottle. You close the cap, but clumsily you dropped it and it rolled behind the gas pedal and the brake pedal. It's a big bottle, I guess. So when you try to depress the brake, nothing happens. That bottle acts as an antagonist. It blocks the action of the brake pedal. Same water bottle, it's behind the gas pedal. It blocks the action of the gas pedal. So that's how you should think of agonists or antagonists. Don't think of increasing activity or decreasing activity, because the brake's normal process is to decrease activity. And that's the case of the parasympathetic nervous system. The gas pedal would be the sympathetic nervous system. So antagonists do not activate. They're usually anti or blockers. So any drug with an anti or blocker, usually an antagonist. Agonists, they're going to mimic the regular process. So a lot of these drugs are called mimics. Decrease sensitivity and increase sensitivity. So extended stimulation, your body becomes desensitized to it. That's what this is meaning. So for example, insulin in diabetics. So if you eat big, gigantic meals all the time, your body's going to dump tons and tons of insulin in the blood. But that's a natural response after a meal. But if there's always high insulin in the blood, your body's going to think it's natural, it's normal, and it doesn't react to it anymore. Opposite is increased sensitivity. So now you've taken away the drug. So what happens is more more receptors will grow. So for an example, this would be tobacco or nicotine cessation. So when you stop smoking, you don't get the nicotine, but your brain will actually grow more receptors because it thinks, hey, I'm just missing it. There's nicotine, but I'm just not catching it. So let's just grow more receptors, and hopefully we'll get some. So that's how your body will naturally respond. Some drugs, you'll have to gradually increase or gradually decrease to prevent any withdrawal symptoms. So for steroids, not the anabolic steroids, but steroids used to suppress inflammation, the corticosteroids, you'll have to taper them off because as they're getting the drugs externally, their body is not producing it. So if you take them off cold turkey at a high dose, their body hasn't had time to adjust. Also, this is important with any antidepressant meds, antipsychotic meds as well. Review question. The site of action is which of the following? I think it's supposed to be D, site of action. The place where a drug causes an effector. That animation's a little. And agonists. So think of the analogy. If I'm an agonist, am I the gas pedal, the brake pedal, or the water bottle? So if you said the gas and brake pedal, you'd be correct. So activation. If I activate the brake pedal, it slows me down, but I still activate it. If I activate the gas pedal, it speeds me up. So those would be your agonists. Yeah, these are in the wrong spot. All right, that looks like that concludes part 1 of basic pharmaceuticals. Coming up next would be part 2. We get further into the drug profile, blood concentration profile. Once again, thank you for joining me today. And if you're not coming in class, I'll see you again next time. Thank you.